Chapter 4, Quadratic Equations. The presentation is structured as follows. 4.1, Introduction. 4.2, Quadratic Equations. 4.3, Solution of a quadratic equation by factorization. 4.4, Nature of roots. Introduction. In Chapter 2, you studied quadratic polynomials of the form ax squared plus bx plus c, where a is not equal to 0. When we equate a quadratic polynomial to 0, we get a quadratic equation. They are used in various real-life situations. History: Babylonians. They were the first to solve quadratic equations. Euclid developed a geometrical approach for finding lengths which were roots of quadratic equations. Brahmagupta, an ancient Indian mathematician who gave a formula to solve equations of the form ax squared plus bx equals c. Sridharacharya, credited with deriving the quadratic formula by the method of completing the square. Al-Khwarizmi, an Arab mathematician who studied different types of quadratic equations. Abraham Bar Hanasi published a book in Europe containing complete solutions for various quadratic equations. Quadratic equations. A quadratic equation in a variable x is an equation in the standard form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. Example 1. John and Javanti have 45 marbles. After each loses 5, the product of their remaining marbles is 124. If John had x marbles, the situation is represented by the equation x minus 5 times 40 minus x equals 124, which simplifies to x squared minus 45, x plus 324 equals 0. Example 2. A cottage industry produces x toys per day. The cost of each toy is 55 minus x. If the total cost was 750, the equation is x times 55 minus x equals 750, which simplifies to x squared minus 55x plus 750 equals 0. Example 1. Mathematical representation. Let's represent the problem about John and Javanti mathematically. Let the number of marbles John had be x. Then the number of marbles Javanti had is 45 minus x. After losing 5 marbles, John has x minus 5 marbles, and Javanti has 40 minus x marbles. The product of their marbles is x minus 5 times 40 minus x, which is given as 124. This expands to negative x squared plus 45x minus 200 equals 124. Rearranging this gives x squared minus 45x plus 324 equals 0. This is the required quadratic equation. Let's represent the toy problem mathematically and check if other equations are quadratic. Toy problem. If x is the number of toys, the total cost is x times 55 minus x, which equals 750. This simplifies to the quadratic equation x squared minus 55, x plus 750 equals 0. Example 2. Check whether the following are quadratic equations. X minus 2 squared plus 1 equals 2x minus 3. Solution. Expanding the left side gives x squared minus 4x plus 5. The full equation becomes x squared minus 6x plus 8 equals 0. This is in the form ax squared plus bx plus c equals 0, so it is a quadratic equation. X plus 1 plus 8 equals x plus 2, x minus 2, x, 2x plus 3 equals x squared plus 1, x plus 2 cubed equals x cubed minus 4. Checking equations, continued. The equation xx plus 1 plus 8 equals x plus 2, x minus 2, simplifies to x squared plus x plus 8 equals x squared minus 4, which further simplifies to x plus 12 equals 0. This is not a quadratic equation because it is not in the form ax squared plus bx plus c equals 0. The equation x times open parenthesis 2x plus 3 close parenthesis equals x squared plus 1 simplifies to 2x squared plus 3, x equals x squared plus 1, which rearranges to x squared plus 3, x minus 1 equals 0. This is a quadratic equation. The equation x plus 2 cubed equals x cubed minus 4 simplifies to x cubed plus 6, x squared plus 12, x plus 8 equals x cubed minus 4. This becomes 6x squared plus 12, x plus 12 equals 0, which is a quadratic equation. Remark, an equation might appear to be quadratic but isn't, or appear to be cubic but simplifies to a quadratic. Always simplify first. Solution by factorization. A real number, alpha, is called a root of the quadratic equation ax squared plus bx plus c equals 0. if a times alpha squared plus b times alpha plus c equals 0. The roots of the quadratic equation are the same as the zeros of the corresponding quadratic polynomial. Example, solve 2x squared minus 5x plus 3 equals 0. We split the middle term, minus 5x, into minus 2x minus 3x. The equation becomes 2x minus 3 times x minus 1 equals 0. The solutions, or roots, are x equals 3 divided by 2 and x equals first. Example 4, finding roots. Problem, find the roots of the quadratic equation 6x squared minus x minus 2 equals 0. Solution, we split the middle term minus x into plus 3, x minus 4x. The equation factors into 3x minus 2 times 2x plus 1 equals 0. Setting each factor to 0 gives the roots x equals 2 divided by 3 and x equals negative 1 divided by 2. Example 5, finding roots with surds. Problem, find the roots of the quadratic equation 3x squared minus 2 times the square root of 6 times x plus 2 equals 0. Solution, we split the middle term into minus the square root of 6 times x and minus the square root of 6 times x. The equation factors into the square root of 3 times x minus the square root of 2 times the square root of 3 times x minus the square root of 2. 2 equals 0. Since the factors are identical, there is one repeated root. The root is x equals the square root of 2 divided by 3. Example 6, word problem application. Problem, find the dimensions of the prayer hall from a previous section, which was represented by the equation 2x squared plus x minus 300 equals 0. Solution, we split the middle term plus x into minus 24x plus 25x. The equation factors into x minus 12 times 2x plus 25 equals 0. The roots are x equals 12 or x equals negative 12.5. Since x represents the breadth of the hall, it cannot be negative. Thus, the breadth is 12 meters and the length is 2x plus 1, which is 25 meters. Nature of roots. The roots of the general quadratic equation ax squared plus bx plus c equals 0 are given by the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. If b squared minus 4ac is greater than 0, we get two distinct real roots. If b squared minus 4ac equals 0, the roots are both negative b divided by 2a. The discriminant. The expression b squared minus 4ac is called the discriminant of the quadratic equation. It tells us the nature of the roots. A quadratic equation x squared plus bx plus c equals 0 has two distinct real roots. If b squared minus 4ac is greater than 0. Two equal real roots. If b squared minus 4ac equals 0. No real roots. If b squared minus 4ac is less than 0. Example 7. Finding the discriminant problem. Find the discriminant of the equation 2x squared minus 4x plus 3 equals 0 and find the nature of its roots. Solution, in this equation, a equals 2, b equals negative 4, and c equals 3. The discriminant is b squared minus 4ac, which is negative 4 squared minus 4 times 2 times 3, 2 times 3, equaling 16 minus 24, which is negative 8. Since the discriminant is less than 0, the equation has no real roots. Example 8, word problem. Problem, is it possible to erect a pole on the boundary of a circular park, diameter 13 meters, such that the difference of its distances from two opposite gates, A and B, is 7 meters? If yes, find the distances. Solution. Let the distance from the pole, P, to gate B be x meters. Then the distance to gate A is x plus 7 meters. Example 8. Continued since AB is the diameter of the circle, the angle APB is 90 degrees. By the Pythagoras theorem, AP squared plus PB squared equals AB squared. The equation becomes open parenthesis x plus 7 close parenthesis squared plus x squared equals 13 squared, which simplifies to x squared plus 7x minus 60 equals 0. To check if this is possible, we find the discriminant. B squared minus 4ac is 7 squared minus 4 times 1 times negative 60, which equals 289. Since this is greater than 0 point, real roots exist. Example 8. Solution. Solving the equation
x squared plus 7x minus 60 equals 0 using the quadratic formula gives x equals negative 7 plus or minus the square root of 289 all divided by 2. This gives two solutions, x equals 5 or x equals negative 12. Since distance must be positive, we ignore the negative solution. So, x equals 5.0. The pole should be erected 5 meters from gate B and 12 meters from gate A.
Example 9. Finding equal roots. Problem: find the discriminant and the nature of the roots for the equation 3x squared minus 2x plus 1 divided by 3 equals 0. Find the roots if they are real. Solution: the discriminant is b squared minus 4ac, which is negative 2 squared minus 4 times 3 times 1 divided by 3, equaling 4 minus 4, which is 0. Since the discriminant is 0, the equation has two equal real roots. The roots are negative b divided by 2a, which is 2 divided by 6, or 1 divided by 3. The roots are 1/3 and 1/3.
Summary. In this chapter, you have studied the following points. A quadratic equation is of the form x squared plus bx plus c equals 0, where a is not 0. The roots of the quadratic equation are the same as the zeros of the quadratic polynomial. The roots can be found by factorization and equating each linear factor to 0. The quadratic formula gives the roots as negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, provided that b squared minus 4ac is greater than or equal to 0. The discriminant, b squared minus 4ac, determines the nature of the roots. If greater than 0, two distinct real roots. If equal to 0, two equal real roots. If less than 0, no real roots.
Thank you for learning with us.